So now we have seen a few things, right? Like in place, um, like axis equals to 0 or 1, so these are very common and peppered across certain functions. Certain because not all functions have meaning when you say axis equals to 0 or 1. So anyways, so when we say dot sum like this, it's not going to sum up everything. It's just going to sum up vertically downwards. Okay, why do we do this? When we perform a column sum for each column like this, yeah, we'll be basically forcing the false to 0 and true to 1. Okay, let me say again. When we do a sum over Boolean values, Python understands that when you sum over Boolean values, false becomes 0, true becomes 1. So with that understanding, all the false here will add up to 0. And because column B here has 2 trues, we get 2. And another 2 trues in column C's and D's, although they are at different positions. So now we have an aggregate 0, 0, 2, 2, 6. What should we do? Because remember our goal is how many cells are there in the whole data frame, right? We almost have it. All we need to do is add them all up. So, but remember, this dot sum ends up generating a series, not a data frame. So fortunately, series has a lot of, in fact, has all the equivalent aggregating functions. So what we do is just dot sum. And there is no need for axis because it's a snake. It just runs through all the cells and add them all up. So we just do a ss6 underscore l dot sum, and that will give us the total. So end up we'll get a scalar value of 6. And finish. That's the end of it. Now, pandas is designed for us to not have to create so many temporary variables. I created them because when learning it first time, we're trying to slow down the action and to see frame by frame what's going on, right? And by assigning to a temporary variable like this, df6 underscore l, ss6 underscore l, we can ask the Python console what is the content of df6 underscore l, and we'll see this, right? But we can also use the dot notation to chain on, and this is a feature that is quite celebrated for pandas. We really enjoy it. We really encourage you to use it to the extent possible. Okay, so what we do is, after a while, you get used to it and say, well, this is, I need a bracket there because otherwise it's not going to really look like a data frame. So this data frame mask is going to be dot summed into a column sum. Okay, and then that column sum is a series, and we dot sum again. Notice that we jump from data frames sum to a series sum, but it's totally invisible unless we pry open using this temporary variable method to really see the type of df6 underscore l and the type of ss6 underscore l. We wouldn't really know that we have gone from a data frame to a series. Fortunately, it doesn't matter because we are trying to answer this business question. How many people in these places are seniors, 60 years old and above, right? So just give me a quick answer, and that is what we have. Dot sum, finish. So after a while, you get used to it and you realize that if I start with a df6, if I do a dot sum, I will get all the total of the entire data frame. So the dot sum essentially is to add up all the truths. How many truths are there in the mask data frame? Because truths are ones. Yeah. Okay, so I hope you get to see in this slow motion analysis how pandas dot facility here allows us to very easily express what we want as a chain on filtering. Okay. Now you might recall that we can do map for series, apply for columns or row vectors, and apply map for each and every element in the data frame, right? We just talked about it in the previous video sequence. Now we can certainly apply lambda functions that return either true or false, or else have a named function that after performing complicated checks, it can be even querying certain dictionary and database, and then finally decide it is true or decide that it is false. Just return a true or false. And then do a apply map or do a, yeah, basically apply map. And once you do that, you will end up getting a data frame mask. And that's it, right? That's it. We know that subsequently you can do all the wonders with it. So if need be, if the content-based filtering expression is complicated, right? It goes beyond just simple and or, and or else if you have and or not or and, you know, like very deeply nested, complicated, then don't try to squeeze everything into a lambda. Put it in the filtering expression. That is just a convenience for complicated checking. Before you return a true or false, you can always put that checking into a function and then invoke apply map to the data frame to return a data frame mask based on your filter function. So for example, if all the rows having at least 2 odd numbers larger than 4. So I don't want to count all the odd numbers like 1 and 3. I want 4 and larger, but it's odd, and at least 2. Okay, so of course, I've purposely created these numbers. So you see that, let's just do a manual identification. The first row here, we do have odd numbers, but they are not 4 or larger, so no count. This one, we highlight the odd numbers, but not 3, because it is not 4 larger than 4, so 5 and more. So we have 2, then we have none, and we have a 1 cell here that is actually 4 larger than 4 and odd, so we highlight that, and 9 and 7, right? But we are not done yet, because we need all the rows that have at least 2 of the yellow boxes. So actually we want only 1 and 6. How do we get that? Now this is getting complicated, okay? And what we try to do here is that we can, for example, write a filter and say that if that content value, for example, 7, right? First of all, it has to be greater than 4. 7 is greater than 4. And it is, after dividing by 2, it leaves a remainder of 1. So that's odd. That means that's our way of testing whether it's odd. So if both are true, 7 will satisfy this, then we return true. If it breaks and even one of them, for example, 3 will leave a remainder of 1 when divided by 2. But it's not greater than 4, so it will fall through and return false. All right. So this is our filter to get all these yellow boxes. But we are not done. We apply map the filter, and we get this data frame here that I've nicely drawn out for you. And we get the picture, right? We get a picture. So DF6 odd is just giving us the large odds, those that are 5 or more, right? That are odd. So the large odds are there, but we need to count them row-wise. Yeah, so we count add up across the columns. So to do that, we need, or the thinking is we need to add across, to sum across. So definitely we use dot sum. But if we do dot sum without anything else, it will add vertically, which is not going to be what we want. So we want to say dot sum, but axis is 1. So it will create a series, so SS6, a series that will contain how many trues, how many big odds there are in the corresponding row. So 2, 1, 2. Now we are ready by performing one more layer of content-based filtering. That is, in this series, the content is the count of large odds. And if the count of large odds is 2 or more, then return a true. All right, so we convert this 0, 2, 1, 0, all these into true or false, such that if it's 2 or more, then it is true. So that's very simple, right? We learned that I won't say day one, but video one, right? So that's very simple. We just say SS6 odd, right? Greater equal to 2, finish. And that will result in a mask SS6 true false that is looking like this. We are getting there already, right? As you can imagine, if we simply say the original DF, so it's DF6, right? Select based on SS6 true false, then we are done. So we will end up getting rows 1 and 6, which correctly identifies the contents to be having two odd numbers that are larger than 4 or more, right? So the other way around, having odd numbers that are larger than 4 and having two or more such occurrences. So that's exactly what we have. Yeah, and of course we can throw away all the temporary variables like SS6 odd, SS6 true false by just dot chaining them all together. So definitely this will work as well. Okay, so now if you are ready, we can then jump over to the lab and really convince ourselves that all these wonders are not just classroom talking. It's really true. All right. So let's hop over to the lab. I mean, see you.